Hello and welcome to our next installment of CIS 224 Data and Information. This video we're going to talk about tables. So we've mentioned tables throughout the course as being crucial to relational databases. And now it's time to answer the question, what exactly is a table? Table is the most important part of the relational database. Without tables, there wouldn't be a database. At least not a relational database. So they are really the building blocks of the database and what makes up the database, the very core of the database. There are other components to a relational database, but the table is by far the most important. So a table is two-dimensional. It contains a few features, but basically it's made up of columns and rows, much like in an Excel spreadsheet. So a column, for example, would in this what we see on the screen would be the phone. So all of those phone numbers down would be a column. Rows are unique and go straight across. So the connect date, the phone, the first name and last name make up, for example, Sue Jones, the entity that is Sue Jones, and the columns would be her attributes. Really, if you want to think of a table, the columns give the table its personality. So by this table we could say that this was probably a customer table. And the connect date, the phone, sort of gives what makes up the table or what the table is about. The rows actually give its substance. So by entering the information into the different fields, we give the table its substance. So continuing along those lines, let's talk about rows and columns. So columns can be called attributes, values, or fields, and store a single piece of information. So the connect date stores just the date that the customer was connected. It doesn't store any other information, the phone number or anything else. Complete date stores when the order was complete and nothing else. The first name, the last name, again, only store what's in there. The column are very important, especially when we talk about SQL. You will use the column names to pull the information back that you're looking for. So you will actually, in your select clause, and again we will get in further down what a select clause is where you will say, this is what I want to see. I want to see the customer's first name and the date that they placed an order. I want to see a product's description and how much it costs. So that is the information that you would pull, and you would actually use the names of the columns. So it's very important to understand the names of the columns in the table. The other thing you will use in your where clause of your SQL statement is the column names to pull conditions. So I want to see the connect dates for the customers that have connected in the last 6 months, and you would use the date range to do it. So it's vital to understand what the data type is for each one of the columns, and the columns are consistent all the way down. Everything will be the same data type. For example, with the data type, if you have a date field in connect date and you say where connect date equals John, you won't get any results back because SQL will be looking for a date range or a date as opposed to a text field. The other thing with connect date is you cannot have duplicate column names. So you can't have connect date and then have another connect date. Each column has to be unique throughout. Again, it's obvious for obvious reasons. If you have two connect dates and you ask to pull a connect date, the computer won't know which one you mean. Now you can use, instead of first name, last name, you could do name 1, name 2, but that's frowned upon. And we'll talk about, when we talk about normalization, that actually breaks some of the rules of normalization when creating a table. So the other part of this is the rows. Rows can be called records and are made up of a series of values. So for a student, it would be it could be your home address, it could be your billing address, it could be your date of birth, your first name, your last name. It would contain your student ID. So it is just one entity. So in a row that contained John Smith's student, say student named John Smith, there wouldn't be any information in that row on Sue Jones or anyone else. So it would just contain their information for just that one single entity. Same thing for a product or an order. You would just contain what's in that order or just attributes of a single product. Rows also contain primary keys, usually contain primary keys. Again, if you're going to follow the rules of normalization, it should contain some sort of primary key. So a column would have a student ID, and in that row, that ID would be specific to that individual, or that product ID would be specific to that specific product. Your student ID is not used by anybody else and never will be within a database. It is unique. So that ID that you have will never be, in all likelihood, will never be reused going forward, which is another reason to make sure that your ID field is large enough to accommodate not only current students but potential students going forward. There can be, in a table, there can be 0 rows. Usually when you create a table, it starts off without any rows, and then eventually you enter rows as you go along. You may import rows from a previous database. You may import it from a spreadsheet if you're going into, say, a server-based database. But initially it could have 0 rows, and the table with that would be referred to as empty. For server-based databases, there is literally no limit to the number of rows that you can house for the most part. Databases holding historical knowledge especially are vast and may have tens of millions of rows. Some of the bigger data for data mining, when you start talking about clicks on a website, they have millions of rows a day or a minute added in. So it's really a matter of how much storage space you're willing to use up for the specific table. For if you're using Excel or Access for a database, there are limits. So Access, especially after about 1 million rows, starts to deteriorate and can't handle something that size. Your column name may limit you on how many rows you have. So let's say you have a column row and state is the primary key, and so you can only have one state. The state may only be represented once in a table. So obviously for the United States you would have 50 rows would be your max for that table. But otherwise you don't have any limits. Excuse me. Tables are not in any specific order. A lot of times it may look like they're ordered by, say, their primary key, but you can't always know that will be the case. So in SQL we will use something referred to as an order by clause excuse me, to pull back the results in the desired order going forward. So we have methods within SQL to make the data look the way that we would prefer it to do. But in the table, it can go in any order whatsoever. So just last sort of, we've covered some of this already, but tables will have stricter rules in their design than say an Excel spreadsheet, even though an Excel spreadsheet could be used to house databases. So looking at this connect date, if you enter it into an Excel database, you could put Smith underneath the database. You could put Bob, a telephone number. On phone, you could put a date or somebody's name. This is one of the issues that you would have with an Excel database, because within each one of the cells you could enter anything that you like. Databases are going to have referential integrity that are not going to allow you to do this going forward. Access, you can set access up to it, and when we look at access, we'll look at the tables and how you would be able to structure it so that Smith would not be allowed to be entered into connect date going forward. And it really is to as you go through, you'll see if you were to look at a table like this, there was no way you could write queries off of that. You couldn't say I need connect dates for the last 6 months with that type of information in it, because those rows would never show up. You can't say where the first name equals John or pull the first names, because you would get the date fields with that kind of stuff. So tables need to be set up very strictly in order to avoid these type of situations. And as we go through relational database and we talk about normalization and how to set up tables, we'll go through how to make sure that this type of entry does not happen. So that wraps up the PowerPoint portion of the first week, topic 1. The next 2 videos will be about access. So we're going to walk through access and talk about how to enter information. We have some spreadsheets that we'll enter that you'll need going forward to follow along for topic 2 or the next week's presentation on SQL, and then you'll also need it for quiz information in order to be able to follow along.